Okay, good morning, everybody. And a happy new year to you all. Well, glad you're joining us again. Thank you so much for your support all through. Thank you. So we're Abuja our user group, and this is our first meetup this year, 2025. So you're welcome once again. I'd like to give a brief intro into the group. We are Abuja our user group, a community of our users and enthusiasts. Okay, just let me bring in this. Okay. Okay. So we're a group of our users and our enthusiasts based here in Abuja, although we have members all over the world. We're really grateful to those who are joining us from outside the country and especially our local participants as well. So thank you all for joining us. So we do have various events. This is one of the events that we have. We engage speakers, those who are more knowledgeable in the industry, using R for exemplary stuff, projects, and whatever you have that you know that, okay, we share with the community is going to benefit all of us. That is what we always engage in. So we always invite people to join us, share their knowledge with us, and let us all grow together. So this is what we are all doing. My name is Bilikisu Olatunji, and I'm a data scientist based here in Abuja. I'm an individual consultant, and I work within Abuja. So it's nice to meet you all. Without taking much of our time, I'll introduce the topic of today. So that is data analysis in our programming. So this is just the topic, but we're going to get more by learning how to analyze time series data. So our speaker is a well-known person and is really qualified to handle this task. So I'm going to introduce him. He's Dr. Kenneth Mwerem. So he's popularly known as the R Malam. So he is an experienced medical doctor and epidemiologist with over a decade of expertise in humanitarian emergency management, community health planning, and disease surveillance. He serves as the Senior Surveillance and Global Health Security Officer at the Institute of Human Virology, Nigeria, where he leads public health initiatives like vaccine coverage mapping and integrated disease surveillance. Dr. Ewarem supports outbreak responses and operational research in collaboration with the Nigerian Center for Disease Control. He is also a certified data analysis instructor and expertise in R programming, statistics, and GIS, contributing to the health intervention across Africa. As a leading facilitator of data science training, he offers advanced insights into using analytics for public health decision-making. So please join me in welcoming Dr. Kenneth Ewarem. So I'm really glad you're able to join us today. Thank you so much. And I want to take over from here. You
Okay,
ready?
thank you so much, Bilkisu. That was a mouth-watering introduction. I was beginning to wonder if that was me you were talking about. Okay,
You
good
are.
morning,
Thank
everyone.
you. Thank
Thank you guys for joining. I know we are all very busy, but it's good to take out some time to have some kind of self-development once in a while. So the topic essentially is actually time series analysis in R programming. Yeah, so we'll just try and see how we use time series analysis to analyze time-dependent data and use that to make actionable insights into public health issues. So without further ado, I will go ahead and share my screen. Okay. Can everyone see my screen and can you hear me? Can I confirm that?
Yes, we can see. I hope everybody can see the screen. I can see
Yes, the
the
screen.
screen. Okay,
Okay,
thank you.
and you can hear me well,
Yes,
right?
I can hear you as well.
Okay, awesome. Okay, so
Thank you, Johnson.
okay, so like I said earlier, this is time series analysis in R programming. Subtitle is Unlocking Patterns, Trends, and Insights in Time-Dependent Data. And I consult for Omega Cares Consult, a subsidiary of Omega Cares Foundation. We do data consultancy and capacity building. Additionally, I also consult with Applied Epi in the US, who also train public health officials on epidemiology in our programming. Okay. So what are our learning objectives? So by the end of this session, we will expect that each of us should be able to understand the basics of time series data and its components. We should be able to explore techniques for visualizing time series data, and we should be able to learn decomposition techniques to extract trends, seasonality, and randomness. We should be able to develop ARIMA models for forecasting, and then we should be able to apply these concepts with hands-on R coding. If at any point you think I am fast or you don't get anything, please stop me, ask me to slow down or ask any questions. Okay, so I'm going to make some assumptions for this training. I believe this is an R user group and everyone should have had some exposure to R. So this is not a basics R training. I expect that everyone should have seen the R environment, the R studio environment, and have some slight knowledge about data cleaning and manipulation and stuff. Additionally, this is an overview of time series analysis, and hence it's just an elementary level course. We're not doing any master's program here, just for us to learn how to use time series analysis to analyze time-dependent data and try to make sense of it. And then as a follow-up to that, I believe there will be a follow-up course to this where we can delve deeper into the nuances of time series analysis. So having these background assumptions, let's proceed. So what is time series data? So by way of definition, a time series data are just data points that are collected or recorded at regular intervals. That's basically the definition of a time series data. And examples of this, for example, in those that are in the climate sphere, will be collecting daily temperature. That will be a time series data, because this data is collected at regular intervals, the interval here being every day. For those in the financial world, the stock price is being collected every week, can also be time series data. So the interval, the regular interval here is every week they collect stock prices. And for most of us here, I believe who are in the health sector, collecting data on disease incidence trends, like number of cases of a certain disease, maybe weekly or monthly, can also be a time series data because there is like regularity in the intervals of this collection. And the key features of a time series data, the time order is critical. So it must have a time component. There must be data or the attributes collected regularly at regular intervals over a given period of time. So that time order is critical. And then the data often shows three critical components. So hidden within this time series data are the trend of the data, seasonal patterns of the data, and then random variations of the data. So when you have when you collect data and you plot it, this is usually what you have, the observed trend. So for example, this is the observed trend for COVID-19 cases in Nigeria between 2021 and 2024. You can see there is regularity in the data collection. It's every month between 2021 and 2024, we had number of cases of COVID were collected in the country. So this is just an observed trend of your time series data. Now, what a time series analysis does is that it breaks this observed trend into three critical components: the trends, the seasonalities, and the randomness, which you'll see on the next slide. Okay, so the figure you're seeing on your right is the time series analysis decomposed data. So the components of a time series are what we're seeing on the left side of our screen. So there is the first graph, which is the observed data, which is what your data primarily is telling you. And so that's just a representation of your raw data over time. So the first graph you're seeing, the orange colored graph, is the same graph that you saw previously. Is this same graph that you saw previously, which is just the observed trend of the disease. So what the time series does, it breaks this observed trend into the three other components that you see below the first one. So the first thing we see is a trend. And the trend is like a long-term movement in the data. So just a summary of how the frequency or the numbers have moved over time. Has it increased? Has it decreased? Is it undulating? So it just gives us a summary of the trend over time. And that is what the trend means. Then the second component is seasonality. In here, the time series analysis breaks or extracts from the observed data to see if there is a seasonal pattern in the occurrence of that event. And in this case, we can see, please, can we all put our voices on mute? And in this case, we can see that there is a seasonal pattern that is occurring in this place. We can see that the event has two peaks. There is a minor peak, which occurs somewhere around August, and there is a major peak, which occurs somewhere around December, January. And that is repeated over the years. You can see again in 2022, again in 2023. So this shows us that there is a seasonal pattern to that disease. And that could be due to environmental factors or, you know, whatever the case may be. But it's showing us that there is a seasonal pattern. And then the third, the last graph, which says random, shows us irregular and unpredictable variations within the observed data. So what essentially it is that anything that cannot be explained by the trend and seasonality is represented in the randomness. So this initial observed trend is broken down into three. We see the trend, we see the seasonality, and then any other thing that is not explained by trend and seasonality, we see it in the randomness. And randomness could be maybe as a result of there was an outbreak, or which could have caused the peaks that we're seeing, or the dips also could have been caused maybe due to public health intervention or something. So you can see there are like two peaks here, which might suggest that maybe there was an outbreak at this time, and then there was a dip here. You might have suggested maybe that there was some kind of public health intervention that caused this dip to happen. So that's the randomness. So again, a time series analysis breaks down our observed raw data into a trend, the seasonality, and the randomness. Okay. So now, what are the steps to execute a time series analysis in R? So the first thing you want to do, which I normally do for any of my projects that I'm conducting in R, is to create a project and link it to a folder that becomes my working directory. So I create a new folder. So we will practicalize this following the slide. We will create a new folder with the name Abuja RUG, which is R user group. And then we will create an R project linking the working directory to this folder. And then we will get our data sets that we want to analyze and place it in that folder. And then we will open and save our R script as time series analysis script. And then we will sectionalize our script into the following sections that we'll see on the next slide. And then we will apply the appropriate codes. So this is essentially the sections of an R script for a time series analysis. So we move from our title, and then we install and load our packages, and then we import our data set, and then we explore, clean, and manipulate our data, and then we plot the raw data, and then we convert the data to a time series format, because before you can work on that data as a time series data, it needs to be converted to a time series format. And then we will decompose the components. So those components that we mentioned earlier, the trend, the seasonality, and the randomness, we will decompose that from the time series data that we have just done. And then we will plot the decomposed components, which will now plot those different components. And then finally, as an addendum to time series analysis, you can also forecast. So apart from describing what has happened with your observed data, you can use the information that is contained in your observed data to forecast or to predict what will happen subsequently in the next 2, 3, 4, 5 years. So, and that is done using the ARIMA model. So we will create the ARIMA model from the time series data we have done, and then we'll summarize the model, and then we'll forecast the model. So these are basically the steps that we, or the sections of the script that we will use to create our time series analysis. Okay. Okay, so let's see some practical. So before we move into R, are there any questions at this point? Can you also hear me?
Hello.
Yes, I can hear you.
Yes, we can hear you.
Yeah,
Okay.
thank you very much, Dr. Ebenezer, right? Oh, no, the Armalam. Yes, let me just put it like that. Thank you for your presentation. Please, I want to know what is the difference between a time series data and panel data?
Okay, I haven't heard about panel data before, so I wouldn't likely know what the difference is between time series and panel data.
Oh, okay. But this time series, is it applicable? Because from your presentation, I realized that you are in the area of health, public health, and so on and so forth. Can this be applicable in social sciences, behavioral research as well? This time series analysis using R.
Okay, so if you remember in the beginning of the slides, I gave examples. So time series is not restricted to a particular sector. Time series is used whenever you have time-dependent data. So any data that you are collecting over time at regular intervals, whether it is in the financial sector, it's in climate, it's in business, it's in sales, it's in health, wherever it is, as long as you are collecting attribute data at regular intervals over time, you can apply time series analysis to it.
Okay, thank you very much, sir. And lastly, sir, is there specify, or let me say, minimum sample size that is a time series analysis must have? And lastly, I also want to appeal that maybe after the session, the R codes that we are going to use for this session should be shared with us. Thank you.
Okay, thank you very much. Okay, so your former question was asking about if there are any minimal amount of data that could be used. So yes, like it's applicable in all statistical computations. In this case, we're analyzing a time series. So we're looking for trends over time. So let's take an example. If I'm looking at stock prices, if I just have stock prices for 6 months, for example, it might not suffice for me to make predictions for stock prices of 2 years, because all I have is for the first 6 months. I don't have a full year that is saying what happens in January, February, March, April, May, June, July, up to December. So in a time series data, it is appreciable that you have at least 2 to 3 years of data, such that you'll see the trends and patterns in each of those years. And that will be able to give you some kind of reliable information as to what is happening in terms of trend, seasonalities, and randomness. Because you see, when you're measuring time, it's usually measured, most likely, you want to see how that trend has happened in a year. January is usually different from February. February is really different from March. But we know once you've done January to December, it goes back to January again and repeats itself. So if you have like 2 years or 3 years amount of data, you know, there are 2 or 3 Januaries in there, there are 2 or 3 Februaries in there. So you can be able to see patterns occurring. You can be able to see seasonalities. So that's that with the data. And the R codes for this, I think you will discuss that with Dr. Bilkisu. She would give you appropriate answers to that. Okay, any other questions?
Okay.
Before we...
Okay, can I just have... Hello?
Yeah, I can hear you.
Okay, good. Please, we're going to share the videos recording as well as the resources from Dr. Kenneth. So please, if you didn't register through the Meetup page, kindly fill the form that has been shared here so that you will be able to send it to you by email. So that is the only way we can resolve this. So thank you.
I see someone, Kamal, raise their hand.
Okay, you can
Yeah,
go ahead, Kamal.
Kamal, can you go ahead?
Okay, thank you so much, Dr. Ken. It's always interesting listening to you. My question is, since you mentioned seasonality and things like that, what if the data was collected at maybe 3 points in time, maybe after 1 week, 2 weeks, 3 weeks, and the time series analysis to be performed? And secondly, I also want to clarify that time series is not the same as survivor analysis. Thank you.
Okay, so thank you very much. Those are very great questions. So a time series gives you better outcomes when the interval of collection of data is regular. It doesn't mean that you cannot use it when you have irregular data collections, like you just mentioned. However, the outcome you get is more accurate and more actionable when you have regularity in your data collection. And yes, time series analysis is not the same as survival analysis. Babatunde, you can go ahead.
All right. Thank you so much for this training, sir. So the question I want to ask is, as this session is going on, can we follow you as you are working on her? Because I have my system here with me. Is it possible for me to just follow you, for it to, sync? Is there a way I can follow you? Because we don't have access to the data set you may want to use. So that's my question. Or is it are we just to view what you are doing? So
okay, thank you very much, Babatunde. So this is a 2-hour session of training. If you think you're fast enough to follow me as I am going on the R, that's fine. But I doubt that you'll be able to catch up because the time is short. So like Bilkisu said, the video will be shared. So if you are really, really interested in following, you can watch the video and apply the same thing, and you will get a data set that you can use to practice. Okay, I'll take one last question and then we can continue if there's any more. Any more questions? Okay,
I think we
so
can give time later for more questions. If you
more
have any
questions.
other questions, just please put it in the chat and we'll be able to attend to it later. Thank you.
Okay, thank you very much, Bilkisu. So we'll just go into R. So like I said, we're going to follow these steps that we listed here. So I said the first thing, we'll create a folder with the name Abuja RUG, and then we will create an R project linking the working directory to this folder, place our data set inside this folder, open up an R script and save it as time series analysis, sectionalize our scripts, and then apply the codes. Okay. So usually what I do is to open up a folder in my desktop. Okay, so this folder I'm going to call, you can see the folder here where my cursor is. I'm going to call it Abuja _RUG and create it. And the folder is definitely empty. And then I'll go to my R Studio and I'll create a project. So I go to File, go to New Project. And then it will open up a dialog box for me. So you can see there are 3 options here: new directory, existing directory, and version control. So we're going to go with existing directory, and that's because we have created a project, a folder already. So that folder that we created, we're going to put in our project inside that folder, and that's why we're choosing existing directory. So I'll select existing directory, and now we'll come here. So we will browse. You can look at this button, browse. We'll browse and locate that folder we just created. So it's on our desktop, and Abuja, you can see that's the first folder here, Abuja RUG. So I will double click on that, and you can see Abuja RUG here. So I'll click on open. So if you look at this working directory now, it's now located in that. So you can see desktop / Abuja RUG. So we're creating an R project inside that folder right now. And then I will click on open new session so that that project can be opened in a new session, and I will click on create project. So that will open up a new R Studio for me. And then if we look at that Abuja RUG folder, you can see the project is already created in there. This is the project we just created inside the Abuja RUG folder, okay? So we are now in the Abuja RUG project, right? You can see it here. And then you can see it at this top left corner. It's also named Abuja RUG Studio. And then, yeah. So the next thing we will do, like the instruction said, is that we'll take our data set and then we'll put it inside that folder. So I'll look for my data. MMF, yes, Flow. So Flow data set now. Sorry, okay. There's a Flow data set. It's not a real data set. I just created it in R. So I'm going to take that data set and I'll put it in our Abuja RUG folder. So that's it. So I'm going to paste the data set in here. Paste. So now I have my data set and the RUG project there. I'll minimize this. And then we will open up a script. So I'll open up, I'll go to File, New File, and then R script. So it opens up this script, and then I will save the script. File, Save As. I want to call it Time Series Analysis. So you can see the name of the script is now Time Series Analysis. And if you look at this third quadrant, I have my script, Time Series Analysis. I have my data set, flu_data.csv, and then I have my project. So next thing, we'll sectionalize our script. So using these sections that I listed here, let's show it to you again. These sections that I listed in this place, I will sectionalize a script. Okay, so let's go back to our R Studio. So the first thing is your title. So in creating a script, in creating sections in R, you use the keyboard, this thing, Control-Shift and R. So once you click Control-Shift and R, it opens up a section for you. And then I can type title and then enter. So it has created a section called title. I do the same thing, Control-Shift and R. The next section will be to create a project. So we've actually done that, but I'll just write it here, create a project. I'm sorry, create a folder in our desktop called Abuja_RUG. And then the next is to Control-Shift-R, create a project. And link the working directory to the Abuja_RUG folder, right? And then the next will be to copy and paste our data set into the Abuja_RUG folder. And then the next will be to create an R script and save it as time series analysis. And then the next will be sectionalize the script. So if I zoom into my quadrant 1, so this is what it looks now. So we have our title, create. So I think this title should come here. So I just delete it and now put it here. So the title will be the first section of the script I'm sectionalizing, right? Okay, and then Ctrl+Shift+R. The next after title is to install and load packages. And then Ctrl+Shift+R. The next is for you to import your data set. And then Ctrl+Shift+R. The next is for you to explore, clean, and manipulate your data. And then Ctrl+Shift+R. The next is for you to plot the raw data. And then Ctrl+Shift+R. The next is for you to convert the raw data to a time series format. And then Ctrl+Shift+R. The next is for you to decompose the time series into its components, which are trend, seasonality, and randomness. Okay. And then the next will be for us to plot the decomposed components. And then the next will be for us to create an ARIMA model of the time series data. And then the next will be for us to summarize the ARIMA model. And then the last thing will be to forecast the ARIMA model. Okay, so these are the steps. Sorry, this is seasonality here. So these are the steps that we will deploy in running our time series analysis data. Okay, so we'll start with title. So title, usually you won't just put in the name. Maybe you're doing a time series analysis training, for example. Author, I'll put in my name. So when you're doing yours, I'm putting your name. I'll put in R. Malam, and then date, can put February 2025, and then email, can put in your email or gmail.com. So that essentially ends our title part. So I'm going to deactivate this so that R doesn't see it as a code. Now, the beauty of creating sections in your script is that irrespective of how long the codes within that section are, you can easily collapse them and it will help the navigation of your script. So if you look at this number 16 where title is, there is a small arrow beside it. If I click on that arrow, it collapses everything I've written under title. If I click that again, everything under title appears, okay? So let's install and load our packages. Some of us might be, there are two ways to install and load packages in R. Either you use the install the packages and library to load, or there is the Pacman style of loading. I have a preference towards the Pacman style of loading. So usually if you're doing that, you will first of all install the Pacman package. So install packages, and then there is Pacman package. And then after you do that, you can now use your Pacman to load other packages you want to use. So we're going to use about 6 or 7 packages. So Real, Janitor, we're going to use Forecast. We're going to use not Git Summary. We're going to use Tidyverse. And then we're going to use GG Animate. So I think this should do. So this is okay for our install and load packages. The beauty of using Pacman is that Pacman installs and loads the packages at the same time. Instead of after installing the packages, we install the packages, you still go ahead again to use library to load. So Pacman does those two jobs at the same time. Another beauty of Pacman is it checks your system to see if that package is already installed. If the package is installed, it skips the installation process and just loads the package. But if the package is not installed, then it will install and then load the package. So that's why I prefer using Pacman, but I mean, you can use whichever style suits you. And then we will now import our data. So I'm just going to run this. So let's come back to our 4 quadrants. So I have run this, this code now to install my packages. And you can see it's run. And then the next thing will be to import my data set. So if you look, we have a data set called flu_data.csv in our files here. And this is the data we're going to import to do our time series analysis with. So I'm going to assign it to flu, or let's just call it flu as the object name, and then we'll assign that to. So again, there are different ways to import data into R. For those that are used to the base R method, you can use the read.csv, read.excel, and etc. to import your data set. But I prefer using the import function, which is within the real package. This real package here has an import function. And the beauty of that import function is that you don't need to know the whether the data is a CSV or an Excel or whatever kind of data it is. You just use your import. But for those other ones of read Excel, read CSV, you need to specify if it's a read CSV or a read Excel or stuff like that. So I'm just going to write import, which is a function. And then I will write my data set the same way it is in my file. So it's flu_data.csv, right? So I'm going to import that, and the object name we're giving it is flu. So if I run this, Control Enter, so you can see flu has been imported and saved as an object in my environment where my pointer is right now, right? And then it's telling us that the flu has 1,000 rows and 5 columns. You can see that over here. Okay. So we can just exploit to look at it. So we can just view our flu. And then it shows us our data set. So it's a data set of symptoms, people that were tested for flu. Like I said, it's not a real data set. I just fabricated it. So it's of 5 states in the US and their respective counties. And then these are the dates of onset of the symptom. And then this is the diagnosis, whether the person was tested positive or negative. So usually this is how your data would come when you want to do your time series analysis. Okay. So are we good up to this point? I don't want to just keep blabbing. Yeah.
Hello.
Let me give a room of
Sorry,
2-3 minutes.
Must our data be in alphanumeric?
In what?
Or we can have a numeric data. I said,
Sorry.
must our data, because when you view the flu data now, I can see that the data is in alphanumeric. It's in string format.
There is string and there is date.
Yes, but my question is it compulsory that the data must be in a string, or can we have numeric data or true?
So numeric like what?
I mean, having what is it called? Maybe like, let's say 20, 25, like that. That's what I meant. Or probably instead of New York, Texas, probably those states have been coded as maybe 1, 2, 3, you know, to denote each of the states in the US.
Yeah, that's possible. You can have your data like that.
Okay.
Any other concerns? Okay, I think I should carry on then. Okay, so we have viewed our data. So usually the way your time series data should the way you want it to be reflected is not the way it is here. What you actually need for your time series data is 2 columns. So you have the date column and the frequency of the attribute, whether it is the number of cases or the daily temperature or whatever. So you have your date, and so it should look like something like this. So I will work on this data now and transform it into what we want our date to look like. So the final data frame I want to call it flu_cases, and then I'll assign that to flu. And then I will group, no, sorry. I want to convert this date, this one, to a month by month date pattern. So I will say mutate. So I'm converting it to month equal to, I'm using the function floor_date. And then the parameter I'm working on is dates of onset. And then the unit I want it to measure in is months. So I'm saying I want to create a new column called month. And then I'm converting this date of onset that we have in our data set to months using the unit called months. So I will do that. Control Enter. Date of onset not found. So let me see how this thing wrote it there. Names flu. Okay, so this is what I want here. Date of onset, copy. And I replace it here. Okay, so I have done that. If we view that flu_cases, you can see it has converted this date of onset into month-like data. So it has converted this into months, right? So the next thing we want to do is now from this to just make the counts of the number of flu cases. So flu cases counts. And then I'll assign that to flu_cases. I'll pipe it into group by months. And then I'll count. So if I run this, Control Enter, so the new data frame that has been formed, you can now see, so it's giving me the counts per month, which is what we just, so this is actually the data you need to do your time series analysis. So sometimes you might get data actually like this. You might get aggregated data like this, which is fine. So you don't have to go through all the process I just did. But if your data comes in this format, this one, then you have to work on it and convert it to this format so that you just have your months, and then this N is like the number of cases in each of the months. Okay. So having done that, we'll now, let's just look at that data and be sure everything is fine with it. So I'll use GLAIMS and then flu underscore cases underscore counts. Control enter. So you can see my month is in a date format. The class is date, and then the number is an integer. So I'm good with my this thing. So I can now just plot the data. Yeah, Frank, go ahead.
Okay, good morning, everyone. Please, can you go through how to convert that data to date and this? I didn't get it very well, please. Thank you.
To date and what?
Into this count, month and count format.
Okay, so I just took the data set, typed it into group by. I grouped by the month column. So this is the data sets. It has a month column, which we had already done. Creating from these dates, we created a month column for it. So we grouped by the month, excuse me. We grouped by the month, and then we counted the cases in each of those months. And that's how we came to this.
All right, thank you
okay?
very much. It's clear. Yes, thank you.
Okay. So we now plot the raw data. So I'm going to use ggplot to do that. So our data set is flu. Let me just so ggplot. So ggplot has 3 arguments I need to give it. So the data, the mapping, and the geometry. So our data is equal to flu underscore cases underscore count. And then our mapping is equal to aesthetics. So on the x-axis, we want to see the month variable. On the y-axis, we want to see the frequency, which is n in that data frame. Then we add our geometry plus geom. So because we're plotting a line graph, we use a geom underscore line, right? So we plot this. So you can see, like I said, the ggplot takes in 3 arguments. So there's the data, there's the mapping, and then there's the geometry. The data is your data set you're working on. The mapping is actually what you want to see on your X and Y axis. And then the geometry is the kind of graph you want, whether it's a line graph or a bar chart or stuff like that. Okay, so if I run this, Control Enter. So if you look at the third quadrant, you can see the graph, the line graph of the data that we just plotted. So it just shows us the pattern that has occurred between 2019 and 2024. I can just zoom it so that we can see it more. Is that fine? Okay, if we wanted to do some slight beautification, we can add color equal to, probably let's use steel blue. We can increase the size to 1.8 and plot again. So it gives us, so the size of the line has been thickened by 1.8 times, and then the color has been changed to steel blue color. So you can play around with that. And then if you also want to still beautify your graph, you can add some more things. So, let's just leave it at this. Simple. So this is our observed trend, right? And then to convert the raw data now to a time series format, because we need this time series format to be able to plot the decomposed version of this. So we'll call it flu_time series, which is the object name. And then we'll convert that data to time series. So the function for that is TS, which means time series. And then we put in our data, which is equals to flu_cases_count. And then we state where we want it to start from. So which usually is the beginning of our data. And our data started from 2019, January. So we combine 2019 and January, which is 1. And then we'll also want the frequency. So because we're doing year, there are 12 months in a year, so we use 12. So this 12 just means that the frequency is like every 12 months. That's what the frequency here means. If we're collecting data daily, we can use frequency here as 7 because there are 7 days in a week. But here, because there are 12 months in a year, that's why we're using 12. Okay, so this is it. So we can run this, and it gives us a time series data. You can just check the class to be sure it did what we asked it to do. So class_flu time series. You can see in the console is telling us it's actually a time series type of variable. And then if we want to view it, you can view flu_ts. So that's what it has converted our data into. Okay, so next is to decompose this time series. So we have our time series data in the format we want. Now we need to decompose it into that trend, seasonality, and randomness. So let's call it decomposed flu. And then the function is decompose. And then we'll put in our data, which is flu_ts. But we're using the value of the number of cases, which is n. Remember, it is n in the data set. This n here. Okay. And then we'll say type equal to additive. So what additive means is, okay, there are 2 types of decomposition that can happen. It's either an additive or a multiplicative. An additive means that the seasonality and the trend. The seasonality is independent. The increase in seasonalities is independent of what's happening in the trend. And the decrease in seasonality is also independent of what's happening in the trend. I hope we get that message. But if it's multiplicative, it means when the trend is increasing, there's also an increase in the cases during the seasons. But in additive, when the trend is increasing, there is the rise and fall in seasonalities remains constant. That's what this means. Okay, so we will run this. Oh, I don't understand. Why is it giving me an error? Decompose flu.
No. Hello, sir.
Just a minute, please. I don't know why it's giving me an error.
It's like you stated the start, but you didn't state the end. I noticed when you were setting up this thing, you stated the
Yeah, yeah,
frequency, but no end.
yeah. You don't really need to state the end. You
Okay.
can do that, but it's not really absolutely necessary to do that. Sorry, let me check my. Oh, okay. Sorry. Oh, sorry. This is where this is supposed to have been. So this is $sign and not here. So sorry, I made an error for the conversion to time series data. Your data is equal to flu cases this. Let me just remove this data here. So it's actually the frequency or the number of cases that you're going to convert. So I'm going to run this again. So Control Enter, and then you can run the decomposed component. Control Enter, good. Okay, so the next thing is we have decomposed that is now to plot the decomposed component. So we just do our plots and then put in our decomposed flu in there. So we run that, enter. And if you look at my third quadrant, you can see the decomposed component. The first being the observed. So this is the observed data, which we saw earlier. And then the second is the trend. So the time series looks at this entire observed data and produces a trend. So you can see the trend is that from a high altitude, it's declined, and then it started increasing again, and then it got to a peak and it declined, and then it started increasing again, and started declining again. So that's the trend over the 5-year period that we are measuring. And then the second or the third graph shows the seasonality. So you can see in between years, there are like 1, 2, 3, 4, 5 peaks. Please, can you put your voice on mute, please? Okay, so if you look, this is 2019, and here is 2020. And you can see there are like 5 peaks in between each year. So there is the first peak, which occurs probably around February, and then the cases fall. And then there's another peak probably around June, and then it falls. And then probably around August, it peaks again, but it doesn't fall to the ground. It falls a little and peaks again, falls a little and peaks again. So this represents the like the ember months, which is usually the cold period. And that's why this flu is more common. So we can infer from here that environmental factors are responsible for this seasonality we're seeing in the flu data. So you can see there's this similar pattern occurring every year. So there are five peaks each year, 5 peaks each year, 5 peaks each year. The first 2 peaks, and then the last 3 peaks, which do not come down, it increases, falls a little, increases, falls a little, increases, and then falls at the end of the year. So that's the seasonality we see in this flu data. And then this is randomness. So every other thing that is not in this data that is not explained by the trend and the seasonality, you see it in the randomness. And there are varying factors that could be responsible for what we're seeing in the randomness. It could be some outbreak, it could be public health interventions that are causing some dips, outbreaks causing increases, or some behavioral practices. So it could be anything depending on the disease and what the literature is about that disease. So this is your randomness, your seasonality, and your trend for this observed data on flu. Okay. I'm going to pause again here. Any questions? Yeah, Oluwatosin, go ahead.
Thank you very much, sir, for the presentation. Okay, can you hear me, please?
Yes, I can hear you, but you can speak a bit louder, so you'll be more audible.
Okay, is this fine?
Yeah, it's fine.
All right. Okay, so I have two questions.
I'm sorry. There was a crack. Can you start again?
Okay, so I said I have two questions. So the first one is,
Please, there's someone that is unmuted. Can you mute yourself? Your voice is interfering with the question.
okay, I'll go again.
Yeah.
I said I have two questions. The
Okay.
first question is for the graph. I can see that we have the month, but then like January.
Oluwatosin, you're gonna have to be a bit louder. Your voice is dimming.
Is it better now?
A bit, but it could be better. It would be more better if it's a bit louder.
I guess the issue is because I'm connected to my laptop. Okay,
Yeah, you can
so,
speak closer to the speaker.
okay, so I'm asking if it's possible to have the date, like the month, listed on the graph, like January, February, March.
Yeah,
For
sure.
proper understanding.
Sure.
That's the first question.
That's possible. Yeah, that's possible.
Okay.
Very good question. That's possible. Yeah.
I really like to see how that is done.
Okay.
And then the second question is, please, I need you to composition.
I lost your voice again.
Can you hear me now?
Yeah.
Okay, so I need you to please explain the section where we have to decompose again. You mentioned two types, the additive and one other type, but I didn't get that. Please, can you re-explain?
Okay.
Thank you.
So
Hello.
you can.
In addition to that,
Yeah.
yeah, sorry. Thank you for the question asked by Oluwatosin. My one is, can you make the graph? Can you add some color to make it more beautiful, like we did for the first one that you added the still blue or something? You know, it looks more beautiful and appealing.
Yeah, sure, you can do that. This is I just use the plot function from base R to plot this. You can fit in your plot into a ggplot and have it look something like this. Where is it now? And have it look something like the one you're seeing on my screen now. Can you see that?
Yes. But we appreciate if you can just put us through.
Yeah. Well, the codes for this are a bit long in ggplots. So, but I can share the codes with Dr. Bilkisu, and then she can forward it to anyone who is interested. So the aim of the training is not to show us how to beautify the graphs. The aim of the training is to show us how to analyze data, how to analyze time series data, which we have seen with the normal plot. However, if you are interested in having codes that will give you beautiful diagrams like this, I will share that with Bilkisu so that you can have it. So that will actually be something like this. So, Tosin, so this is the addition of the dates in months. Is Tosin there?
Yes, I am.
So this is the addition of the dates in months. So all of that can be done. It just requires extra code, and I will share the codes, everyone. Any other question?
Yeah, my hand has been up.
Yeah, please ask.
Can I go ahead?
Yeah, please go
Okay,
ahead.
thank you so much. Thank you so much. For me, it's very informative and insightful. I just want to have some clarity on the interpretation of the analysis. So in terms of the random, the one that is random, I want to know what additional information is it providing. For example, looking at the COVID-19 data you analyzed initially, and you want to talk about randomness of the data. What information exactly, yes, are you trying to pass across looking at that, the random, what's it called? The part that is you have tagged random. What additional information? I understand seasonality, I understand the trend, but the random, I don't really know what information you're trying to pass with that analysis. Thank you.
Okay, thank you very much. That's a great question. So now your overall data is this first one that we're seeing. This one that is in, is it orange color, right? So this orange color, which is observed, is decomposed into trend, seasonality, and randomness. So when you remove trend from this observed and remove seasonality from this observed, the remaining data is what your randomness shows you, which is any other thing that is happening in your observed data that cannot be explained by the trend and cannot be explained by the seasonality. So I gave two examples. So for example, this COVID data, this upsurge or these peaks here might be probably happening at festive periods, and people were gathering for festivities, and therefore the transmission dynamics had increased and there were more cases. This dip that we're seeing here could also be maybe, okay, government instituted some kind of public health strategy, maybe what did they call that thing that happened again during COVID? Social isolation or something like that. Maybe such kind of public health strategies. Lockdown, very good, thank you very much. Such things might have been instituted and it brought the disease. And so all this can be found out with your knowledge of the disease and what is in literature. But just know that randomness means every other thing that is happening in the data that cannot be explained by trend and seasonality. So, but the reasons why they are happening or their interpretations will be now left to the researcher to dig deep into that domain and find out, okay, what were the events that happened around the point of this peak? Or what were the events that happened around the point of this dip that could now begin to infer us to the possible causes of these fluctuations, these irregular fluctuations in the disease occurrence. I hope that answers your question.
Yes, thank you very much.
You're welcome. Any other?
Yes, please. Good morning, everyone. Armala,
Good morning, sir.
Yes, sir. Sorry, apologies, I joined a little late, but I can see the last code that was projected. I saw that we're able to display the time series in different formats, the observed, the trend, seasonality, and randomness. But my question is, apart from just displaying our data in this form, can time series be used for prediction?
Yeah, sure.
And
We are going to get to that part. That's when you use your ARIMA model. We're still not done.
okay,
So it
thank
can
you.
be used to forecast future events. Yeah. Thank you. That's a very great question. Okay. Any other before we move ahead?
Yes, please. My second question has not been answered yet.
Okay, so yes, thank you very much, Tosin. So I'll try to explain again using this diagram here. So when we say additive, you can see this trend here is decreasing, right? The trend is decreasing. However, the level of seasonality has remained constant. So that's what we call that, or that's what is referred to as additive, right? In multiplicative, there's a proportionality between the decrease in trend and seasonality. So if the trend is decreasing, you will also see that the peaks of this seasonality is also decreasing. Or if the trend is increasing, you also see that the peaks of this seasonality is also increasing. So that's what the additive and the multiplicative options mean in that decomposed code. I hope I've been able to answer your question.
Yes, thank you very much.
So let's take one last question if there's any before we move ahead.
Yes, sir. Please, as
Yeah.
you mentioned, sorry, a question just popped up. As you mentioned, the last statement you made about additive and multiplicative, before you run your code, at what point do you determine if your data set is additive or multiplicative? Is it after running the offset or after running the trend? Thank you.
Okay, right now I cannot answer that question because I don't have the information, but I would look at it and I will get back to you.
All right, sir. Thank you.
Yeah, thank you. Okay, so well, let's move ahead. Okay, so now that we have plotted our decomposed data, now let's see how we can use the time series to forecast or to predict future occurrence of an event. So the first thing we do is that we will create an ARIMA model. So just quickly, let me get here. Okay, so ARIMA model is one of the most versatile models that is used in forecasting for a time series analysis data. And that is because it engages the use of 3 different components on the time series. So ARIMA actually means, I'm just write it down somewhere. It means auto-regressive integrated moving averages. So that's the full meaning of the ARIMA, ARIMA, auto-regressive integrated moving averages. So, and these 3 things are 3 different components of things that ARIMA uses. So the auto-regressive part, the integrated part, and the moving averages part. Like I said earlier, this is just an elementary level course. We're not going deep into anything. Most likely there will be a follow-up. So I will keep explanations at elementary level at this point. So how we do that is that we use a function called auto.arima, and then we impute our data sets, our time series data set. For us, it is flu_TS. So let's call it ARIMA model, and then we run this function on it. So Control Enter. So that where's am I running it? Did I run it? Uh-oh. Control Enter. Why is it going back here? Oh, this is a problem. Okay, so that has gone. And then we can summarize, we can do a summary of it, although this does not, is not part of the diagram that I want, but we can do a summary of it. That chunks out some figures. I don't want to go into this now. Then the next thing we'll do is to forecast the ARIMA model that we just created here and on line 69. So let's call it forecasted flu, for example. So we forecast the ARIMA model, and then we add the argument H equal to. And what this H equal to means is how many months extra do we want to forecast? So what 36 means is 3 years. We want to forecast for the next 3 years. So 12 times 3 is 36 months. So that's what this H equal to 36 means. So if we run that, it gives us a forecasted object, and then we now plot the forecasted object. So let's just change this to our flu. And then we run that, Control Enter. So let me expand this. Okay, so this is what it has chunked out for us. So the initial part, you see this line is the original observed data. And then what you see in this last part is the ARIMA model, or the forecast. This blue line is the average forecast for the next 3 years. And then the dark ash background on it is like the 80% confidence interval of this blue line. And the grayish lighter part is the 95% confidence interval of this forecasted line. So that's the prediction that this ARIMA has given us, that given the occurrences in these last 4 or 5 years, that we expect the average occurrence of a disease to be around, if I trace this line to this place, to be around 13 or 14 thereabout. 14, 15 cases. Can see that? So that's the average we expect, given the information we have previously. But because of the uncertainties and the irregularities and the randomness that is happening, it gives itself an 80% and 95% confidence interval, that even though this is the forecasted line, there is a margin of error of 80%, that is this, and 95%, which is this. So this is the prediction part, or the forecast part of your time series analysis data.
Right.
So
okay.
Let's take questions.
Okay, Edward speaking.
Dr. Kombu, good afternoon, sir.
Good afternoon, sir. Thank you very much. Thank you for the great job thus far. I just want to make some inputs, and maybe I joined and then along the line I dropped out because of network, and then I changed my position and rejoined. So I don't know whether this was done. However, in time series, we have other factors that determine the accuracy of a forecast. When we have data, one of the key things is the stationarity of the mean. And then when we look at that, we try to look at the ACF and the PACF to ensure that all the spikes are within the acceptable range, so that in our forecast, we have a reliable and good forecast. So I was thinking that will be captured before we move to the forecast. I don't know whether that was done before.
No, that I actually skipped that because I didn't want to, like I said in the beginning, this is just an elementary level stuff. I didn't want to bombard us with so much thing in this one session.
Okay, sir.
I'm sure there will be a follow-up to this. If you look at the code, what you just mentioned now, not on this, on my own document. So this is what you just mentioned now, the autocorrelation function and the partial, but I just intentionally left it just to make the class more elementary for us to just understand the basic concepts.
That is noted.
Time series. Yeah.
Thank you, sir. Well done.
Thank you.
Okay. Good morning, sir.
Good morning.
Good morning. Thank you very much for the lecture. Very, very informative. Thank you. I'm just curious, actually. I look at this time series and I see that it's actually very useful, but it works basically with you having a particular set of raw data. Now, my question is, can this be used for like a form of literature review where the data has already been, the work has already been performed, and you want to check, literature of some authors, combine it together and use it to predict forecast what is coming in other things? Is it possible, like we have in bibliometric and the rest, is it possible we also use time series for literature review?
Thank you, Femi, for that question. Yes, I would say yes to that. Whatever, if for those literature review, if you can access the raw data that was used for each of those reviews, yes, you can use a time series analysis to forecast for those, once you have access to the raw data that was used in the analysis. Yeah, next person, please.
Hello.
Yeah, Adebanjo,
Yes,
go
sir.
ahead.
Actually, sir, it's like I got lost when you were explaining the ARIMA focus graph. If you can retake it again, sir.
Sorry, say that again.
Yes, please. Good morning, everyone.
Hello. Can you please assist in explaining the ARIMA focus graph again? Thank you, sir. Did you hear me, sir?
Yeah, I heard you.
Thank you.
So again, this initial part you're saying, the one with the lines, is the observed data, the trend of the observed data, which is the data we have from 2019 to 2024. Then this part that is shaded is the forecast. And what is giving us is the average occurrence that it expects, which is this blue line. And if you trace this blue line to this point, is around 14 or 15 thereabouts.
Okay.
So it's expecting that the average cases between 2025 and 2028 will be 15, the average cases, right?
Yes.
However, because there are uncertainties, there are randomness that have occurred over time, it's giving itself a margin of error with a confidence interval of 80% for this dark part, this dark gray part, is the 80% confidence interval of this forecasted line. And then the lighter part is 95% confidence interval of this forecasted line.
Okay.
So that's the explanation. Thank you very much.
God bless you, sir.
Next person.
Okay.
Hello. Okay.
Okay, please, excuse me. Hello. Yeah, please, a little bit.
Okay.
Excuse me. Please, there's a lady that has been trying to ask a question. That's Zoo. Okay, I think, I don't know if she's left. She's been struggling. Okay, I think she left. Okay.
Okay.
Okay, you can go ahead.
Okay.
So, sorry, before you go ahead, Bilkisu, maybe since you are observing the hands, maybe you can call names first before each person asks the question so that we have an orderly.
Okay.
Yeah.
Okay then. Thank you. Yeah, I will do that.
Yeah, so go ahead. The person that was asking.
Okay, apologies. I was actually thinking Madam Bilikisu was not on the call. Maybe she was busy. That's why I was trying to intervene, like the way people were asking questions. As
Okay,
Dr.
thank
Kenneth
you.
said
Thank you.
earlier, so I think this is a kind of a basic class or section on ARIMA model, which I believe we are still going to have further sections. So basically, as he mentioned earlier, on that even ARIMA alone, talking about autoregressive integrated moving average, I could observe that we are using the auto ARIMA where we are just taking into consideration the order, the integration, and even the moving average as 0. So it's something we can still go on further, maybe to change the order, the integration, and even the moving average, which is known as maybe ARIMA PDQ. I realize that some people were just asking questions around this. I believe the theoretical part of it, maybe we are still going to have another section where doctor is going to explain this further. So that's why I just wanted to chip in because of the kind of questions people were asking. Yeah.
Okay, thank you so much, Fidelis. Thank you for standing in. Actually, I was kind of occupied with something. So please, I'm really appreciative of that. So Zoo, can you go ahead and ask your question? I think she's online now. Hello, Zed. Hey, you were trying to ask a question and you've been unmuted. Can you ask your question now? Okay. Okay, I think maybe we can go ahead. She's maybe network, I don't know. I think she's just in and out. So doctor, maybe you can continue.
Okay. Okay, so that's the practical aspect of the time series analysis and ARIMA model forecasting we just saw. There are some other advanced topics that one could want to explore on your own. We have the seasonal ARIMA. We also have the multivariate time series analysis. If you notice, the ARIMA time series analysis focuses on a univariate analysis. So you can only look at one variable over time, but there are other models that look at multivariate time series analysis that you could want to also explore. There's also the integration with machine learning for hybrid forecasting models. So key takeaway I expect we take from this course is the importance of understanding time series components of a time-dependent data, ARIMA as a powerful tool for forecasting, and then the role of visualization in interpreting data, and then try your hands on the codes and see that you get them and master the time series analysis codes. Yeah. So that brings this to an end.
Great. Highly commendable.
So I hand over to you, Bilkisu.
Okay, hello?
Yeah.
Okay, I'm sorry, kind of lost it there. Okay, I think we've come to the end of the session, I think.
Yeah,
Hello?
that's what I was saying. I said I'm handing over to you. I don't
Okay,
know if there
yeah,
are
thank you
any
so
other
much.
questions. If there are any other questions from any other person that we want to take before.
So if you have any other questions, please kindly signify, or we're going to be rounding up. And I believe Doctor has a kind of a program that he would like to announce or get you people familiar with. So maybe you should do that while we're waiting for other questions.
Okay.
Thank you.
Let me share my screen and do that quickly. Okay, so can you see my screen?
Yes, we can.
Okay, thank you very much. So in our Omega Cares Consults, we have also some couple master classes that we organize. These are paid though. We have the geospatial analysis class, which is what you're seeing on your screen now. And we also have the infectious disease modeling class. So these three series, the time series analysis, the geospatial analysis, and infectious disease analysis are like our master classes that we hold in Omega Cares Consult. And then we also have the basic we also have the basic class where we delve deep into data analysis in R programming, where we teach you the R basics, data exploration, data cleaning, wrangling, data description and summarization, data visualization, and analysis. We actually demystify those R codes and make it very, very simple for you to be able to analyze your data and make sense of it. So I'll drop my email in the chat. So if anyone is interested, they can easily reach me via email. So I just put my email on the chat. And that's my WhatsApp number. So you can easily reach me, and then we can have that discussion. Any questions before we call it a wrap?
Yes, sir.
Yeah, please go ahead, Stephen.
Thank you so much for the class. I enjoyed every bit of it. But my question is, this Abuja R user group, is it a community for R users? How do one join, and what are the benefits? Thank you.
Okay, I will defer the question to Bilkisu. Hello, Bilkisu, are you there?
Okay. Okay. Yes, I'm back online. Thank you. Yes, the community is for our users and data enthusiasts. So we basically focus on using R for our work and for all the researches and programs we do. So it doesn't mean that we don't collaborate with other people who are using other languages. So we have different means of kind of collaborating with others. So, but basically we are focused on using R in our field of work. So you're welcome to join the community. We share knowledge, we share whatever we learn, the expertise, we network. So this is what we do. Basically, most of our meetups are online, and sometimes we do organize in person. So that's what I would want to say about R. So, and we're also being funded by the R Consortium. So we're being supported by the R Consortium, and we have the another group that's for the ladies. Men are also welcome to support us. So it's to just bridge the gap between diversities. So these two communities are based here, Abuja, our user group, and our ladies Abuja. So you're welcome to join. I think Fidelis, if you can help me, I'm actually driving out to attend to an emergency here. You can share the WhatsApp group that we're using, and you can join us. We do have monthly programs that we engage in, and also other programs like we learn and share study groups and the likes. I hope that answers your question.
Absolutely. Awesome. I'll be happy to join. Thank you, Pelekesa, and everyone.
Okay. Thank you so much. So, Fidelis.
Okay. All right. All right.
Are you
Thank you
there?
very much, madam. Thank you
Okay,
very much,
please can you
everyone.
round up? I'm attending to something else. Thank you so much.
All right, ma. All right. Thank you, Dr. Kenneth. Thank you, every participant, for your contribution. And we are Abuja R User Group, as Madam Blikisu has rightly said. So it's a community of R enthusiasts where we assist ourselves. If you are very familiar with R, or you use R in your work, a place, and you are interested in teaching others, or you want to learn from others, so that's what the community is for. So we come together. Sometimes we may create different classes. Maybe you want to be under geospatial class, you want to be under econometric class, you want to be under biostatistics class, different classes. You can join any one of your choice. So that's what we do there. I believe we have shared the link to the WhatsApp group earlier. Let me try to trace it again, if I could share it. Or let me just drop my contacts, WhatsApp contacts, in case you're willing to join. You just reach out, then I'll try to invite you. So I just dropped my WhatsApp number in the chat box. You could please chat me up if you're interested in joining, then I will share the link with you. So that's what we do there. All right. Thank you everyone for participating in our training today. And hopefully this is a kind of monthly training that we do. So we hope to see you in our next class or sections, as we'll be sharing the links to different sections that we'll be having. Thank you everyone for participating. And I've just dropped my contact in case you want to join. Thank you everyone. So yeah, Abuja, somebody is asking a question, is it free or paid? So this group is free. That's why I say it's a community of R enthusiasts. So we come, we share knowledge. So however, there are other courses. We have professionals who also have their different courses that they train people on. If you want to, for example, maybe geospatial, you want to have a kind of advanced knowledge, so you can reach out to someone like Dr. Ken, who is also into this. So I believe that's going to be a kind of paid version. So we also have option for that. Yeah. Do we still have any other question?
I saw Ifoma Iboga's hand. I don't know if she still has a question.
Hello, good morning. Thank you, Doc, for the presentation. I don't know if I'm taking us back, but when you carried out the ARIMA analysis, you used the function summary to print out the results from the ARIMA model, but I don't know if you could just spare a few seconds to explain the output. I know you explained the plot, but the output from the model, I don't think I I got
Yeah,
that bit
so
of the
that
class.
was intentional. Like I said, this is just an elementary course. Probably if we have a second cohort of this training, we will dive deeper into those. But I didn't want to complicate things at this level. I just wanted to ensure that we knew how to use the time series analysis to get our decomposed components, and then just make a basic forecast with the ARIMA model.
Okay, that's fine. Thank you.
You're welcome. Okay. Thank you, everyone. I'm
All right,
really
thank
very
you, everyone. I've
grateful
also
that
dropped
you
the invite
spent
link
your
in
time
the
to
box.
come out for this training. Let's keep in touch. Let's keep learning. Let's keep growing. Let's keep pushing. From over here, Armalam, I sign out. Bye.
All right. Thank you very much, Doc. So I've also dropped the link in the chat box. So you can just click on the link to join the Abuja Arisa group. All right. Thank you, everyone. Bye for now.
Thank you. Bye.